Hello friends, welcome. So this is the case 1 where we are discussing about the Routh criterion. This is the characteristic equation. Now we have to find whether the given system is stable or not. For that, the same procedure we have to follow. We have to write the powers in the descending order. S power 5, S power 4, S power 3, S power 2, S power 1 and S power 0. Now the second step is we have to write this coefficients. S power 5 we will write 1, 2, 3 and that's all. For S power 4 what we have 1, 2 and then we have 5. Now do the same procedure that I have told you earlier. 1 into 2 minus 1 into 2 by 1. What we get? 1 into 2 minus 1 into 2 by 1. We get 0. When we get 0, we cannot proceed further. So this is the case 1 where we get the first row. When we are calculating the first row, we get 1 0. This is the first case. When we get the entire row, when we get the zeros, then this is the second case. So now here we are getting 0. We cannot write 0. So for that reason I am taking epsilon here for calculation purpose. So when I am writing epsilon, then I can move further with my calculations. And at the end of the problem I can write 0 again. Here we are writing epsilon because its value is very low. That is the reason why we are using epsilon here. So now I am getting 0. I am replaced it with epsilon. Continue further. 1 into 3 minus 1 into 5 by 1. What we get? It is minus 2. Now the same process again. Epsilon into 2 minus 1 into minus 2 by epsilon. That is, we get as 2 epsilon plus 2 by epsilon. And again epsilon into 5 minus 1 into minus 2 by epsilon. We get 5. Now this thing into minus 2 minus epsilon into 5. We get 2 epsilon square minus 4 epsilon minus 4 by 2 epsilon plus 2. Then this thing into 5, this thing into 0 by the whole thing. This and the numerator term will get cancelled. We'll left with 5. So this is the array that we got. Now the second step is that we have to substitute 0 in the place of epsilon. Now I am substituting 0 in the place of epsilon. Then I'll get 0 minus 2, 2 into 0 plus 2 by 0. We get infinity. This is the 5 itself. Then s into 0 square minus 4 into 0 minus 4 by 2 into 0 plus 2. We get minus 2. Then s power 0, it is 5 itself. Now you can observe that we are having two sign changes in our Routh array. That is minus 2 to infinity and the other one is minus 2 to 5. So by seeing itself, we can say that the given system is unstable. So you're having this S-plane. You're having two sign changes, that is minus 2 to infinity, and another thing is you have minus 2 to plus 5. You have two sign changes. So we can say that the system is unstable. Because the two roots are lying on right of S-plane and three roots are lying on left of S-plane. Total we have S power 5, so 5 roots are existing. In that 5 roots, 2 roots are lying on the right side and the other 3 roots are lying on the left side of the S-plane. So when we see the roots on the right side, then easily we can say that the system is unstable. Thank you.